Teknologi dan salam sejahtera untuk kita semua. Perkenalkan, nama saya Desak Putu Ariska Diri atau biasa dipanggil Ariska. Saya adalah dosen Teknologi Pangan di Institut Scientia Internasional Indonesia. Pada kesempatan kali ini, saya akan membahas salah satu mata kuliah yang saya ampuh, yakni Food Processing Unit Laboratory dengan bobot 1 SKS. Video ini dibuat sebagai salah satu persyaratan sertifikasi dosen gelombang pertama tahun 2025 pada bagian penyusunan dokumen pernyataan diri dosen dalam Unjuk Kerja Tridharma Perguruan Tinggi. Mata kuliah Food Processing Unit Laboratory ini menggunakan metode DEI atau Delivery Interaction and Assessment. Mata kuliah Food Processing Unit Laboratory ini merupakan mata kuliah wajib bagi mahasiswa semester 3 di program studi Teknologi Pangan. Adapun bahasa pengantar yang digunakan adalah bahasa Inggris. Mata kuliah ini bertujuan untuk mengenalkan mahasiswa pada berbagai jenis unit operasi yang digunakan pada proses pengolahan pangan, seperti low and high processing, mixing, frying, encapsulation, drying, dan extrusion. Mata kuliah ini akan membahas prinsip mekanisme bagaimana suatu proses bekerja dan dampaknya pada keamanan dan kualitas makanan. Setelah mengambil mata kuliah ini, mahasiswa diharapkan mampu mengoperasikan berbagai alat berskala pilot dan mengaplikasikan berbagai proses pangan baik dalam skala laboratorium maupun pilot lab. Adapun capaian pembelajaran lulusan atau CPL yang dibebankan pada mata kuliah ini diantaranya, lulusan akan mampu menunjukkan kualitas kepemimpinan dengan menginspirasi dan motivasi orang lain, memimpin tim menuju pengambilan keputusan yang berdampak dan beretika, serta memberikan kontribusi positif bagi komunitas atau organisasi. Lulusan akan mampu bekerja dan berinteraksi melalui komunikasi lisan maupun tulisan secara efektif dalam tim yang beragam, menumbuhkan semangat kerja sama dan saling menghormati, serta memanfaatkan kekuatan kolektif untuk mencapai tujuan bersama. Lulusan akan mampu merancang dan mengembangkan sistem pengolahan pangan terintegrasi dengan menerapkan prinsip-prinsip ilmu dan teknologi pangan untuk menghasilkan produk pangan yang bergizi, berkelanjutan, berkualitas tinggi, dan aman dalam skala industri. Yang terakhir, lulusan akan mampu mendemonstrasikan dan menginovasi operasi teknologi pangan yang kompleks dengan mengintegrasikan teknik analitik pengolahan pangan skala pilot dan sistem manajemen mutu. Sementara itu, adapun capaian pembelajaran mata kuliah atau CPMK terdiri dari mampu bekerja sama dalam tim untuk mencari, mengevaluasi, dan mengumpulkan informasi guna merumuskan solusi serta mengkomunikasikan hasilnya secara ilmiah, mampu menjelaskan pengaruh pengawetan, metode pengolahan, dan variasi bahan pangan mentah terhadap kualitas pangan, mampu melakukan teknik analisa pangan untuk menilai atribut mutu pangan, dan mampu menggunakan operasi satuan untuk menghasilkan produk pangan yang aman, berkualitas tinggi, dalam skala laboratorium ataupun pilot plant. Adapun materi pembelajaran mencakup blanching, chilling, freezing, emulsification and homogenization, vacuum frying, spray and freeze drying, dan yang terakhir extrusion. Sistem pembelajaran yang diterapkan berupa praktik secara sinkronus dengan metode pembelajaran berupa ceramah, diskusi, demonstrasi, dan eksperimen. Mata kuliah ini dilaksanakan selama 16 pekan di mana terdiri dari 9 kali praktikum utama dan 5 kali pengamatan hasil dengan 2 kali ujian berupa UTS dan UAS. Mata kuliah ini memiliki 9 kali penugasan yang berupa penulisan hasil laporan, UTS dan UAS yang merupakan ujian praktik. Penilaian didasarkan pada grading rubrik yang telah tersedia di dalam RPS. Adapun bobot penilaiannya mencakup UTS sebesar 27,5%, UAS sebesar 27,5%, kuis sebesar 10%, laporan praktikum sebesar 25%, dan partisipasi sebesar 10%. Adapun untuk UTS dan UAS merupakan ujian praktik yang didemonstrasikan langsung di laboratorium. Total bobot penilaian adalah 100%. Pada kesempatan kali ini, saya akan menayangkan cuplikan video dari salah satu sesi praktikum di sesi 11. Adapun sub CPMK yang ingin dicapai mencakup mahasiswa mampu menunjukkan kemahiran praktis secara individu dan atau dalam kelompok dalam menjelaskan pengaruh career agent selama proses spray drying terhadap atribut mutu pangan melalui kegiatan pemrosesan skala pilot plant dengan interpretasi hasil yang akurat, dokumentasi tertulis yang jelas dalam bentuk laporan terstruktur. Dengan indikator utama, ketepatan dalam menjelaskan fungsi masing-masing komponen pada alat spray dryer, ketepatan dalam menjelaskan mekanisme dan prinsip kerja proses spray drying, menunjukkan kemampuan dalam menyiapkan sampel dengan perlakuan career agent yang berbeda untuk proses spray drying dengan tepat, menunjukkan kemampuan yang tepat dalam menganalisa sampel, serta kejelasan dan ketepatan dalam menyusun laporan hasil praktikum secara terstruktur dan sistematis. Demikian informasi yang dapat saya sampaikan. Berikut merupakan cuplikan video dari salah satu proses pembelajaran praktikum pada sesi 11 yang saya laksanakan secara sinkronus di pilot plant. Selamat menyaksikan.
Okay, good morning everyone. How are you doing today?
Good.
Okay, great. Thank you. So today we are on the session 11 and 12, and this topic is about spray drying process. Yeah. So this is part of the food processing lab, and what we want to make today is basically natural colorant. Okay. So I believe you have studied this principle of this equipment before during the class, but then today, because this is a practical class, so then we will do practical things. Yeah. So what is the objective of this session is that by the end of this session, then I expect you will be able to explain the component of the spray dryer equipment, and then know the procedure and also the principle itself. And then you will be able also to apply different types of wall materials, because today we'll utilize the two wall materials, and then analyze the effect of the emulsifier. And then because it's a practical session, so you will be able to demonstrate to operate the machine, the spray dryer machine, demonstrate the ability to do physical analysis, because today we also assess some kind of moisture, color, hygroscopicity. And then lastly, because this is again practical work, so as usual, you will work in a group, in a team, and then after that you need to make a review. Yeah. Okay. So before we start, this is the outline. So we'll just begin with short introduction, and then the procedure, and then lastly is in the review. Yeah. So previously, I already uploaded some kind of video on how to use the spray dryer equipment. So have you watched this before? Yes? Okay, very good. So, Wika, can you explain to me the principle of spray dryer?
The first one is emulsification, second one is vaporization, and the third one is the chemical emissions, fourth one is the cycle, and last one is the food.
Okay, very good. Yeah, so you already watched this video, yeah? So basically for this procedure, then we basically, the main principle is the same, like you explained, like you obtained from the class, is that we first need to make an emulsion, and then after that go by the atomization process, evaporation, and then lastly we obtain the fluid. Okay, so let's begin directly to the introduction with the spray drying process. Yeah. So with the spray drying process is quite common technology actually in the food industry, especially to make a powder. Yeah. But other than make a powder, what is also important with this spray dryer equipment is to do some kind of encapsulation process, which is what we want to achieve by today. Anyone can give an example of product that made by spray dryer machine? Milk powder. Okay, Daniel. Cocoa powder. Anything is powder basically, right? So this is an example. Like blabber, we also make a blabber with the spray drying, and what we want to make today is colorant with the spray drying, basically. Okay. and this can be used as a natural colorant. And this plant is actually indigenous plant from Papua. Yeah, people from Papua already use this plant for a food colorant, and it's known to have a high antioxidant due to the beta-carotenoid content, and also it has a bright orange-red color. Yeah, because of that it uses natural food colorant. So you can see this is basically the oil. But the main problem, because this one is oil, then it's easily oxidized. That's the first thing. Second, of course, because it's oil, then it has a very limited application. Yeah. So you cannot just apply it to the water. Yeah. And then because this one is also oil, then it has difficulties when you want to handle it. Yeah. So in terms of the convenience, it's not so convenient. So that's why what we want to do is basically to convert this, to encapsulate this into a powder, so that it's wider application, solubilized to water, and yeah. And if we're talking about the encapsulation process, so as you learn from the class, encapsulation is basically a process to protect the core material, yeah, with the wall material, let's say. So you can see from here, the white is a core material, which is basically bioactive compound, the red fruit oil that we want to protect, and then the gray color is a wall material. So anyone can give an example? Wall material with M, A, yes, maltodextrin. Yeah. So that's the most common wall material that can be used basically. Yeah. And this encapsulation process will resulting into different types of encapsulate. Yeah. An example of this is that, for example, this is a reservoir types, which can be done if you do spray conservation process. And this one is metric types, and this one is coated metric type. Yeah. So if you do spray drying process, basically, I will resulting into this metric type. So the core material will be kind of evenly distributed, so not really into one. Yeah. And then, yeah, of course, because of that, there's a possibility that this might be leaking. Yeah. Okay. So this is the overview of this experiment today. So first, we have this oil, and then after that, we make an emulsion. Yeah. So you know how to make an emulsion before, right? And then just mix it for 5 minutes and check if there is no any separation, basically. And then after that, we add the basically to make this emulsion, we use the sodium caseinate, and there will be two wall material, which is the maltodextrin and whey protein as isolate. And then we spray dry it, and then we get this powder. And then after we get this powder, and then we analyze this yield, color, hydrolysis capacity, and then we store it for 1 week. Okay? Okay, so this is the spreading parameter. So this is basically the same as in the lab protocol, so you may check it again. Yeah? And this is the analysis that we will be doing by today. So we'll of course calculate the yield because it's important for industry. We will calculate the moisture content for the stability. And then we will also calculate the flowability to know how to handle this powder during storage. We will also calculate the hydrolysis capacity to know the ability of this powder when it's absorbing the water and then how stickiness. Of course, we don't want that, yeah. And of course, because the application is as a colorant, then we assess the color. Okay? Okay, before we go into depth, do you have any question? Yes, Stephanie?
What if the temperature is too high or too low?
Okay, that's a good question, yeah. So basically, for today, we're using 150 degrees Celsius, yeah. If the temperature is too high, basically the process will be faster. So it's efficient in drying rate. But remember, because we use a red fruit oil, which is very sensitive, so then there's a possibility that it might degrade the carotenoid content. But if the temperature below 150, then there is a possibility that the powder will stick on the chamber, which is also undesirable. So that's why for this type of oil setting, 150 is used. Hope that answered the question. Okay, so as to remind you again, if some of you forgot to
This video consists of three main parts: component of spray drying, preparation of the emulsion, process and principle of the spray drying. So first we go to the components. The components of spray dryer consist of control panel, drying, atomizer, hammer, cyclone, feeding pump, and powder collection bottle. So the first component is control panel. It is used to control and also change the setting in spray dryer. In this panel, you can actually turn on and turn off the system, adjust the inlet temperature, adjust the atomization, air hammer interval, and other important parameters. And then second, there is a drying chamber. In this drying chamber, a constant flow of heated air will transfer its heat to the droplets to evaporate water in the solution. So before running spray drying, you need to make sure that the drying chamber is actually perfectly locked. And then on the top of the inside drying chamber, there is an atomizer that will disperse the solution into small droplets. And then on the bottom, there is a hammer which is used to avoid clogging inside of the chamber. Cyclone system will separate the powder from the airstream and allow the powder to be collected into the powder collection bottle. And there is a feeding pump. Here you can adjust the flow according to the viscosity of the solution. And the last component is a powder collection bottle. So now moving on to the sample preparation. For the feed solution, we need to make an emulsion. The materials needed for making 2 liters of emulsion are red fruit oil, emulsifier, wall material, and water. For making the emulsion, we use hand mixer with a speed of 10,000 rpm. First, mix the water with the emulsifier for a while, and then add the wall material gradually while mixing. For the last part, red fruit oil is slowly added to the solution. And then you see that the color starts to turning orange. We will mix the solution for 5 minutes and make sure there is no separation and emulsion is stable before we put it into the spray dryer. So before start, you need to make sure that all pipes are clean and then the pump behind this spray drying machine is already submerged into the water. Then we go to the control panel. So turn on the spray drying machine and wait until the control panel is on. Turn on the fan, turn on the heating. Well, the inlet temperature, fan, feeding pump, and other parameters already set according to the spray drying parameters that you already see in the previous slide. And then we need to wait until the inlet temperature reach 150 degrees Celsius. After the inlet temperature has been reached, turn on the atomizer. In this case we set it to 150 Hz, right? And then turn on the feeding pump. You can put the pipe into the water first before put it into the feed solution. So this is actually to make sure that the feeding pump is clean before we use it. And then turn on the hammer by placing and connecting it through the compressor pipe. So don't be surprised because the hammer will sound like this. Then open the valve to collect the powder from the cyclone. Now we change it with our samples, with our emulsion. So the emulsion, how does it work? So the emulsion from the bigger glass flows through the pipe and first enters the atomizer, which is located on the top of this drying chamber. The atomizer will disperse the emulsion into the small droplets, and then the small droplets of this emulsion fall through the drying chamber and then contact with the hot air. So during this process, evaporation occurs very quickly. After that, the dry powder will fall to the bottom of the chamber, then transported into the cyclone. The cyclone will separate the powder from the airstream, and then eventually the final product can be collected from the bottle. In short, the spray drying itself consists of 4 main steps. First, atomization of the feed solution. Second, contact of the spray with the hot gas. Third, evaporation of the moisture. And then lastly is the particle separation or cyclone separator. Finally, after the whole procedure, we get the powder, dry powder like this. Store the powder inside the aluminum foil pouch and then add the moisture absorber inside, and then after that seal it. So keep at the room temperature, and then we will do the analysis every week.
Okay, yeah. So you already watched the video, and I hope you now have a better visualization on how we'll conduct the lab today. So in the end of the session, you need to make a report. Yeah. So this report for the formatting, please check the lab protocol. And then for this folder, you need to store it for 1 week. And then you need to tabulate all of the results in this graph. So make sure to get the yield, moisture content, fluidity, hygroscopicity, and color in LAD value. And measure it today and also next week. Yeah, don't forget to do that. And then after that, you need to make a report in a group. So make sure to answer this question, but don't forget to state the objective and the overview of this experiment. And then don't forget to create tables. And then after that, explaining what is the effect of different wall material to this to the properties. Yeah. So this is the reference, and of course, as usual, before we begin our lab session, don't forget to wash your hand, and then we just begin to this practical session. So hopefully you get better understanding by doing this. Okay, is there any other question?